Welcome to Reverse Engineering the OS, a practical guide. My name, one of them, is Mike Lynn. As of late, I am now a client platform engineer at Facebook. Just started in June here. Thank you. The other names I go by, I have to do this in all my talks. Mikey on Twitter, pudquick on GitHub, frogor at the MacAdmins Slack, which I highly recommend that you sign up for if you're not on there. We're over 11,000, approaching 12,000 users at this point. It's free. Just visit macadmins.org, get yourself a login, and come join in all the fun with the rest of us. Also, my rarely published at blog, michaellynn.github.io. So, who should hear this talk? If you looked at the talk track details, they color-coded it, and if you clicked on the details, they had tags for what type of talk it is. This was marked as a advanced development talk. Ideally, the people that would probably have the most to take out of this talk would be someone who either has an interest or a capability in writing code. However, even if you don't, first off, for those who don't, I definitely want to applaud you for taking the first steps towards leveling up your skill set by being here. Programming is definitely a multiplying factor, a multiplying skill to have under your belt. If you're interested in it, I'd highly recommend it. It turns the power of one person, yourself, into the power of tens, hundreds, thousands. Write something once, run it everywhere. Never repeat yourself, let the computers repeat yourself. Secondly, I also want to let you know that I've tried to make this content pretty accessible and interesting no matter what your skill set is. So really, this is for all of you. If it ends up just going in one ear and out the other, if nothing else, hopefully you'll end up leaving here with a sense of the possible. Maybe down the road you'll be able to join in and have all the fun with the rest of us. But I hope everybody gets something out of this. So with that being said, let's dive in. Reverse engineering the OS. How do we do our jobs on a daily basis? Majority of people in here today are Mac administrators. Administrators come in a lot of different flavors. One real common aspect of administration is using, as I mentioned earlier, just a few people to do a lot of things for lots of other people. We spend our time so that others don't have to spend their time, often very expensive time. It would be really horrible if, in order to do that, I had to do everything that I was saving other people their time in real time. Like, if I was saving 10 people 8 hours, I don't want to do things for 80 hours. So the way that we solve that is that we have tools. We have all sorts of automation that we take advantage of in order to do things quickly, fastly, without a human actually being involved. At a basic level, Apple ships a ton of automation capability in the operating system in multiple ways. They ship command line tools like defaults or security or system setup, dsconfig AD for binding to Active Directory. Yet things like profiles, which you all should hopefully be really getting to know by now. They're really important these days, which you can install either using the profiles command, or you can install it with like an MDM or something like that. MDM itself is an automation tool that, again, highly recommend you start looking at it if you haven't looked at it recently. And then at a sort of a deeper layer, there's programming APIs. Apple has a huge collection of APIs that you can write code to touch to make the operating system dance and do things in various interesting ways. Open source projects out there, beyond what Apple provides with the operating system, there's a huge community of open source projects for automation. Monkey, Chef, Puppet, Imager, Nomad, AutoPackage, all of these projects, they are they're open source. You can see how they do it, and if you look inside it, they are using the tools that Apple provided to, and the APIs that Apple provided to provide entire workflows and mechanisms for managing your devices on a grand scale, doing reliable software installs, sometimes on behalf of the user who may not have administrative rights on their devices. In addition to open source, there's also commercial and free products that are closed source tools built by other organizations like Deploy Studio or Jamf or FileWave. For these, you can pay for some of these tools and get actual human support to help you out. But even these tools, under the hood, it's all the same blocks. They are all relying on what Apple shipped with the devices in some way, shape, or form to make your Macs do things in an automated fashion. Open source, closed source, it doesn't matter. We're kind of at the mercy of what we get. Everyone's doing it. The open source, you can actually see it. You can go look and see how it's done. But again, commercial products, it's all the same. So those blocks, who isn't it the same for? Well, Apple, for one. They actually have more blocks. They're hiding in plain sight. Those blocks are in things like GUIs that don't have a command line component piece to them. A GUI is meant for the end user to make a change or a configuration in the operating system that there might not be a public API to do that same change. There may not be a command line tool that's shipped with the operating system to make that same change. There may not be a profile to make that same change. Sometimes it's not a configuration change. Sometimes it's a menu that you click on and it shows you some data, like what SSIDs are in the area. That particular example, there are tools that can do that, but there are other places in the OS where an end user can just visually click on something and see something, get a list of data that from an enterprise standpoint, gosh, it would be really awesome to be able to collect that data centrally. So that kind of begs the question, can we take their blocks? Can we use the ones that Apple's using? And the answer is yes, sometimes. And for any of you out there that immediately had that thought, you probably are a big brother with, or sister and with siblings or something like that, and shame on you, it's hard to overcome a lifetime habit, but anyways. People say, aren't you supposed to be filing radars if that functionality is missing? There's been several talks that have been given here today about if you try to do something in the operating system and you don't have a command line tool and you have a business use case for it, shouldn't you be filing a radar with Apple telling them, we need this functionality now, and explaining the impact and all that kind of stuff? You should be telling them, these are the settings I need, why it's important, the impact if you can't do it, alternative methods possibly of doing it, definitely the number of Macs that are affected. And the answer about whether or not you should be doing this is yes. 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 Filing the radars is still massively important. But in the meantime, you still have to do that job. You file that radar and you tell Apple, I need to do this thing, and in the meantime, the reason that you're even looking at trying to figure out how to do this is possibly because you have a need in your business right now. Maybe it's a security issue, maybe it's an audit, maybe you have a user that is super effective at being really loud. You need this functionality now, and the radar that you file and should file might get fulfilled in the future, but in the meantime, you still have that job to do. So that brings up a different question, is this kind of thing okay to do? So, I am not a lawyer. I would highly recommend that you talk to one if you have that question. in the United States and the European Union and various other locations that have laws regarding reverse engineering. Most of them actually specify something in regards to interoperability. If the purpose of your reverse engineering work is to increase the compatibility of the software you're looking at with other software that you have, like for instance, Puppet or Monkey or Jamf or some configuration product you have, if the purpose is to make them mesh better together, then there are actually usually exclusions for that. What we're talking about here today, we're not talking about bypassing security in the OS or digital rights management or something like that. I'm not talking about that kind of thing here. We're not hacking on security systems. Apple generally doesn't like that. They may even take something that you don't realize is possibly a security vulnerability, and they may actually decide that it is a security vulnerability and stop you from doing it after the fact if they find out that you've done it. So we're not talking about trying to bypass security mechanisms here. We're talking about making things run smoother, making them run faster, saving time, making people happy. You could actually even go a step farther and say that the goal here is actually to keep your organization using Macs. If things are too bumpy to manage these kinds of things, if it's too difficult to do this kind of stuff, if it causes too much pushback, you tell the org, well, I can't do the thing that you're asking me to do, and they come back and they say, we really need to do this. It may actually, if it becomes too big of a problem and takes too long to figure out how to do, if it's important enough to your organization, it may actually trigger a possible move away from the Mac platform. So in one respect, doing this kind of thing can help smooth out and keep you on the Mac platform while you work with Apple to close that gap in functionality via the radar channels and all that kind of stuff. So getting back to reverse engineering, where are these blocks that Apple is keeping and not letting us play with? Well, we're not going to steal them, we're just going to borrow them. The blocks come in a couple different forms, two major forms really. So the one that we really can't do anything about, and I'm not really going to talk about reverse engineering any of this kind of stuff today, is the modern security architecture that you'll see a lot now these days in the OS, which is XPC-based processes, where there's a background daemon that is 100% self-contained, usually has a launch daemon associated with it. They fire up, they maintain state internally. There's like log D, sec D, disk arbitration D. These types of processes are basically an entire whole unto themselves and responsible for doing something, and all the logic for doing it is internal to them. And they're very restricted, locked down. They have superpowers, but they also will only talk to you through the XPC protocol. And when they do that, they can see who's calling and say, I don't want to talk to you. You're not in my approved list of callers. Go away. It is not something I'd recommend trying to spend a whole lot of brain power on reverse engineering this stuff. A lot of this architecture stuff is behind the scenes in iOS. It's really good. The other type of block that you see in front of you is applications, menu panes, menu bar items, preference panes that link to dynamic libraries and frameworks. Rather than being all the code in one self-contained little binary, it's actually enough code to show you something in front of the end user, but the real meat of it is all in this separate library code that's reusable by lots of different pieces of the operating system. That's our meat and potatoes as far as right now for reverse engineering goes. There is a huge amount of this stuff on the operating system right now. Some of it is public. That's the stuff that's in the system library frameworks. There's a huge API, the development docs on Apple's website. But there's a whole other collection of the stuff that lives under system library private frameworks. That stuff's not documented at all, and there's a lot of powerful stuff under the hood. And in fact, actually, some of the private stuff is stuck under the system library frameworks It's just not listed anywhere on Apple's website. They've just kind of tucked it away inside there. A lot of times the giveaway for whether a code is private or not is that either it starts with an underscore. None of the public Apple APIs start with underscores. Or you just literally, I don't know, Google it and you get like 0 hits. That's probably a pretty good indicator too. Where to start? So if what you're interested in collecting information from or doing the same thing you see a GUI for in a more automatable fashion is a menu bar item, then you would want to look for the .menu bundle. If it's a preference pane, look for the .pref pane. Most of them live in system/library/preference panes. Each of these actually has an executable at the core that will link to these frameworks and dynamic libraries. They have a specific structure. Apps too, they're actually a folder. You open them up and inside them is a contents folder and macOS, and then inside that is the actual core executable. This is our target. You look at the menu, you find the .menu bundle, you drill down into contents macOS. That executable inside there is the thing that you're going to want to start reverse engineering. The first step is that you're going to want to start to inspect that application to start to get a sense of where the pieces are. Some of the basic ones you could start off with that come with the operating system, they might require an install of Xcode or the developer command line tools. The first time you run the tool, it'll actually tell you with a nice GUI prompt that you need to install one of these two things. And after that, the command line tool will just run for you. So the first one we're going to talk about here is user bin OToole. OToole can do a whole lot of things, but the thing that we're most interested in is the ability for it to list those frameworks and dynamic libraries we were talking about that are linked to this menu item or preference pane that you're interested in. It lists them all and shows where they can be found on your operating system volume. So the way you do that is OTool-L, and then the path to that contents macOS executable. The output looks something like this. So in this particular example, the contents macOS Spotlight, we ran OTool against that, and it spit out a whole bunch of frameworks that it's linked against. And you can see in the list there, some of them are under system library frameworks, some of them are under system library private frameworks. Some of them are in some other locations on the operating, on the volume. There's probably going to be, on the more complicated things, like literally dozens of things in here. Now, this is good for finding these, but the stuff that you see in the list, if only one item is used out of one of these frameworks, and these frameworks can contain hundreds, thousands of functions and classes and stuff like that that you can call. If only one item is necessary to be used by this tool, this program that you're looking at, it'll show up in the list. So that means that a lot of the stuff that's in the list is probably not anything that you're actually interested in. This is helpful to find out where everything is at, but it's not an indicator of what's being used by what. So that actually takes us to our second tool. The second tool is user bin nm. The nm tool can list the names of symbols that are in an application or executable and tell you which framework or dynamic library they came from. So these are the actual things directly used by the executable. I said, you know, a framework may contain tens, dozens, hundreds of things in it. NM will show you the one thing out of all those that is actually being used. So the syntax for that is nm-m, and then again, the path to the executable. The output for this ends up looking something like this. Unfortunately, the picture there is a little cropped, but there's just a whole bunch of information. But the part that you really want to look for is external versus non-external. When you see non-external for an item in the list, that is code that is only found within the application itself. Probably not your target for reverse engineering. That code is in the preference pane or in the app. It's not in the dynamic library or the framework, so it's very hard in most instances to actually tap into and use. Frameworks and dynamic libraries, we can write code that connects to them and uses it and runs it. code that's in an app itself, the way that you use that code is you launch the app. And we already know that the app doesn't do what we need right now. So it's not really useful for these non-external items. A special case to that is that menu items, .menu bundles and .preference pane items, .pref panes, they are actually loadable code in that there's a host process that you load the bundle into, and then the code executes within it. It's more advanced to use that kind of thing. I'm not really going to cover that aspect of it, but I just wanted to make mention of non-external isn't the end all, like, oh, I guess I have to ignore that. In some cases, like menus and preference panes, you can actually use it. What we are looking for is, can you guys see that okay? What we are looking for is the ones that say undefined external. The ones that say undefined external, they are not defined within the application itself. It's just a symbol name that is external to the application. That's an indicator that it's in a dynamic library or a framework. And you'll see in parentheses at the end of the line, from, and then it'll be the name of what framework it is. But this tool, unfortunately, only just lists the name. It doesn't show the full path. That's why we needed the OTool command. The OTool command, you go back to the output of that one, and you look up core services, and it'll actually give you the /system/library/frameworks/core services.framework. Like, it'll tell you where it actually lives. So between the two of them, you can use nm to find the actual things that you might be able to take advantage of, and then OTool output will tell you where those actually live on your disk, where they are on the computer. You can actually add one extra flag on there, nm-mg, and it will actually filter the output to only the things that are external and leave out all the things that are from within the app itself. So once you've got this list of possible APIs that you might be able to mess with, now's the part where you get to play detective. So again, these are potentially private things with no public documentation. But you still have to figure out, you got to figure they've got some level of internal documentation about what these things do, hopefully, or comments in their code or something like that. And you would hope that the names you saw on the list are relatively descriptive of what they do, or probably related to what they do. I mean, it makes sense. I mean, there's actually, ObjectiveC kind of encouraged that. ObjectiveC was a very verbose API language where it was like, shove 20 words together and that's the name of the API. So because of where macOS came from, a lot of the APIs are very descriptive names. And they should be mostly related to what they do. So you're not going to see, something completely different name-wise. If you're looking for a specific thing, chances are specific thing will be in the name of the API, like set specific thing or get list of specific. This is the part where you got to use your brain a little bit and play a little bit of a guessing game here. Like, for instance, in the example that I had earlier with listing the functions that are in Spotlight, I was looking for Spotlight exclusions. Spotlight is one of those things that there is a GUI interface for the end user to click a button and add a path to be excluded from Spotlight. But there is not a, you can turn off Spotlight indexing for an entire volume, but you cannot GUI automate the exclusion list that you see in that preference pane. Sorry, you can't command line automate that. There's no piece for that. So I wanted to see how the preference pane does it. So Spotlight exclusions Spotlight's all about indexing metadata. So putting on our spelunking hat here, back in that list, there were a couple that showed up as undefined external with a couple of those underscores in the front of them that I was talking about that had MD, copy exclusion list, MD set exclusion. Boy, that sounds really kind of right in the ballpark of the stuff that we're looking for here. Sometimes you need to know more about the underlying operating system to see these types of patterns. Like the metadata stuff, The background service for Spotlight on your computer is called MDS. And if you actually look up the man page on that, it says it's called the metadata server. So by knowing more about your operating system and knowing the possible names that something may be called, you can match more things in the list as possibly being related to what you're looking for. You're not just a detective, you're a researcher here. The code that you're looking for may not be immediately obvious without like additional context or clues to help it stick out more. And even then, you hope that the name for the function is related to what you're looking for, but there may not be an obvious giveaway in the list of names as to what code is doing what you're looking for. So at that point, I'd like to introduce my next favorite tool, Hopper. Hopper is a Mac disassembler. It is a pay-for application available from hopperapp.com. It also has one of my most favorite trial modes, which is download the app, and the core functionality that we're going to be talking about here today, you can do in trial mode. The stuff that is only in the pay-for mode is some interactive debugger stuff. We're not going to cover that level of detail as far as disassembly goes here today. The stuff we're talking about here today, you can completely do with the trial mode. I recommend you download the app and try it out if you're interested in this kind of thing. I paid for the app, and I really love it to death. And I hope you guys support the developer for it. I hope Hopper sticks around for a long, long time. What the disassembler does is you feed it an application, and before, these command line tools that we were using, they just listed stuff. They didn't really show you how stuff was connected other than this binary is connected to these frameworks. It doesn't show what calls what or anything like that. That's what Hopper does. Hopper, if you go looking for one of these symbols, you can trace around and see how that's all connected. And I actually wrote a little bit of a demo program here to use with Hopper to show you kind of the A to Z process for doing disassembly and figuring out, reverse engineering how something works. The TrickyGro program. The TrickyGro program is amazingly powerful. I have absolutely no idea how it's doing what it's doing on the screen. I super need to be able to tap into that same amazing powers that it has to grow numbers. I want to find out the code that it's using to do this, and I totally want to take advantage of it and write my own tools to automate things the way TrickyGro does. So the TrickyGro binary, we're going to run it against the tools that I mentioned earlier in here. So running OToole, the first tool that I mentioned on here against TrickyGro, lists the things that it's linked against. Not a whole lot. There's 3 items in there. There's a foundation framework, which pretty much most applications are linked against. Again, same with libsystem. There's libmy dynamic dynamic lib, but that's not really descriptive. Doesn't really say what it does. Not really anything in here mentioning growing or being tricky. So let's try the nmTool. So we run nm with mg, that extra flag I show on there, so it shows the symbols that are from outside of the application. And again, not a whole lot of helpful stuff in there. There's something about random and something about misleading name, but nothing in here that says tricky or grow in here. So what do we do? What do we, that can't be it. What do we do? We do have the messages that TrickyGro prints out. 12 plus 2 gives the answer 14. 10 plus 2 gives the answer 12. That plus 2 gives the answer part is constant and doesn't change. There's something about the program that generates this message that's something we could go hunting around in the program and see who's making the blah plus 2 gives the answer blah. So again, Hopper, as I mentioned, is really good at following along the connected dots on here. So can we actually use Hopper to find out what code's making these strings show up? So before we hop into Hopper, you can use another tool that comes with your operating system, user bin strings, and you just run it directly against the application, and it'll actually list out if any of these strings, these constant strings, are anywhere to be found in an application or executable code. So we'll run it against TrickyGro. Didn't get anything out of that one. Well, there was that dynamic library, libmydylib. Let's try it maybe against that one. Oh, okay. So the dynamic library has %d plus 2 gives the answer %d. This looks like a string to me, a constant, something that it'll use over and over again and fill in the blanks. If you're not familiar with programming at all, as you get into it, you'll realize that %d is a format string for taking a number and putting it into a string. So this is exactly actually what we're looking for. So let's explore it with Hopper. So the first step is to open up Hopper and use the read executable to disassemble menu item. Do not use the open menu item. The open menu item is for continuing where you left off with Hopper. For starting on a new project and looking at an executable from scratch, you actually want to use read executable to disassemble. When you do this and you choose the contents macOS executable, or in this case, the dynamic library, a whole dizzying array of options are going to show up to you. If you're just beginning with this kind of thing, just click OK. All of those options are set to relatively same defaults. It's fine. Just click OK. And holy cow, now you're disassembling a program. And God, what is that in the middle? And I really just, do I know machine language now? I don't, yeah, so seriously, just hold on a second. The interface is really, there's a lot of powerful tools in Hopper. Hopper under advanced usage is really crazy, powerful, and cool. But the interface can be very bewildering at times. For what we're talking about here, you only need a very small subset of it. So we were talking initially about tracking down a string. What's making that string? What's making the +2 message happen out? So the cool thing is, in the top left, there's actually a little string tab that you can just click on for the executable that you're currently disassembling here. So you click on that, and it switches to a list of strings. Well, hey, there's the guy that we saw earlier, the guy that we were looking for. So if you click on it and select it, on the right-hand side, it'll jump to where in the program that string is defined and highlight it. It's telling you the offset of where it's located. You don't need to know any of that stuff. We want to find what touches this, what calls this. So what you're actually looking for at this point is you are looking for, under the navigate menu, is references to highlighted word. When you select that, you'll get a dialog that pops up on the screen that shows you who's calling this string. Who's talking about this string? Where is this in the application that's being used? In this particular example, there's only one item in the list. You can select it and click Go, and it will jump to the next part in the program where it's located at. Now here for our example, it's kind of tiny on there, kind of a little hard to see, but it doesn't look like a lot of code. It looks like the string again a second time. It's kind of almost like an alias, like we gave this string a name, and the name we gave it was CF string underscore D plus 2 gives the answer, like a truncated, like basically inside the program, the program gave that string a name to call it. So we'll just do what we did before. Again, we'll go to the references menu again and see who calls the name of this string. Oh, now we're getting somewhere. Our good, totally unsuspicious friend, MisleadingName. He's the only guy on the list. So let's select that one. When you select that one, now we see what looks like some machine language assembly code here. And our string is listed in there. So now we're looking at the actual code of this function, and it is referencing the string. So this guy's doing something with this particular string. And I don't know, for a lot of people, including myself sometimes, I'm feeling like the dog with the goggles again right about now at this point. But this is one of the reasons that I love Hopper. And a lot of people don't talk about this feature enough, and I just wanted to make sure it gets out there that people understand that this is out there. Under the window menu is a really, really powerful command. New tab, no. Show pseudocode of procedure. The show pseudocode of procedure command, when you select that, when you're looking at this assembly code that Hopper's pulled out of your executable, out of your application here, it will actually take all that assembly and turn it into, sometimes, a pretty decent job at what maybe the original source code was that generated that assembly. Now, I wrote a very simple demo version of an application for this. In real life, when you do this, there's going to be a lot of junk in here. But maybe every other line or something, it will look like maybe a human could actually understand this code at face value. So in this particular instance here, you can see the NS string with format, and and in point of fact, I actually, underneath that there, is the actual original code versus what Hopper figured out based on the assembly. Hopper didn't have access to my source code. The guy who wrote Hopper is amazing. And he made it possible that in some situations, it can get very close to the original source code. Again, disclaimer, you rarely get perfect examples like this, but sometimes you come out really lucky. The pseudo, one side note here, the pseudo mode, when you go into it, you can actually flip back and forth between the assembly mode with these little buttons that are up at the top. The ones that says move add is assembly view, and the ones that say if b fx, that's pseudocode mode. So if you find yourself stuck in one, you can switch back and forth between the some. So let's go back and look at this again. So the disassembled code that's on here, now we might have kind of an understanding of how this string is being used. It's a string, there's a number, and a number plus 0x2, which is the hexadecimal number 2. It just basically adds 2 to a number, and it puts in the two numbers, and then prints it to standard out. So now we kind of understand what this code is doing. So how can we actually use this code? Let's say I really wanted to use this thing in my own tool and do something different with it. How can I now do something with what I've found here? So to understand that, at this point you need to go back to the executable that was calling this code and see how it's calling and using it. So once again, we use the read executable to disassemble, and this time we aim it at the TrickyGro executable itself. So opening that up, instead of clicking on the string tab, because we already know where the string is, it's in the dynamic library and it's being used over there, now we want to see how TrickyGro calls MisleadingName. So instead, we click on the proc tab to see the procedures in the program and find MisleadingName in the list. Clicking on its name, if you left yourself in pseudocode mode, it will just go straight to pseudocode instead of showing the assembly. Clicking on the name, you see, again, sort of that alias thing that was going on before. This is the program setting up the connection to the dynamic library, saying when someone calls MisleadingName, we go out over here to MisleadingName over in this dynamic library. And again, much like before, we can do, under the navigate menu, we can choose an option to see who's calling this. The syntax this time, since we're looking at procedures, is show places calling this procedure. When you select this menu item, it will show what other function is calling this function. So when we do that for TrickyGro, we get one item again, the main program. So let's double click on main and see how TrickyGro uses the MisleadingName API. So we click on it, and the main function is very simple. It calls MisleadingName and passes it a random number with, let's see, hex 63 is what, 99 plus 1? Basically, it's a random number from 1 to 100. And then it passes that to MisleadingName. So now we know how to call MisleadingName. It just takes a number. You just pass in a number and it does the thing. And we're not doing anything with, there's no result coming back to us. We just call it and MisleadingName handles it and does the rest. So now we have enough details to build what's called a signature. A signature is basically a combination of how many things do I need to give a piece of code for it to run, and in what order do I give it those pieces, and then what do I get back as a result. Misleading name, again, didn't seem to return anything. And the things we need to give it is just a single number. So we have our signature pieces. Returns nothing, takes a single number. So once we have our signature, we can start writing our own code to connect to it. So I like to use Python to do that a lot. If you're not familiar with my blog or my Twitter feed or hanging out with me on Slack or anything like that, I do a lot of Python. It's one of my favorite languages to work with on the Mac for connecting code together. It's an interpreted language, which means everything you write is in a text file. It doesn't ever get compiled to a native application that's a black box to hand to the next person. You hand them the text file, and they can look inside, and they can see what it does, and they can make changes to it. And it's great because from a collaboration standpoint, it's just a bunch of people working on text. You can use whatever text editor you like. There's some great ones out there. Sublime Text, I'll give a shout out to that one. But what's cool about Python is it's on every single Mac in this room. Comes out of the box on every single Mac. In addition, Python comes with a built-in module called ctypes, which is meant for connecting to dynamic libraries, like the one we were just looking at, and calling code that is not part of Python. And as a bonus, Apple actually ships a third-party module called PyObjectiveC, which allows you to connect Python to ObjectiveC APIs, which is like the vast majority of macOS and private frameworks and all that kind of stuff. This is not part of Python stock. You go to python.org, it's nowhere on the site. It's literally a third-party external project. Apple has just decided to ship it with the operating system, and it's increased the power of Python on all of your machines 100-fold as a result of that. You can write PyObjectiveC code, a Python script, a text file, and pass it out via Casper or Monkey or whatever to all of your Chef, Puppet, doesn't matter. Pass it out to your machines and just say, run this thing, and they can all run it out of the box. You don't need to install any additional stuff on those machines. You could just chmod plus X and just run it directly on there, and no extra tools installed. Just here's my text file. It's a program. Here is an example of doing the connection. So with the signature information that we had before, it doesn't take a whole lot to make the connection to ctypes via ctypes. The ctypes module, we choose that one because, again, we're working with a dynamic library, libmydylib.dylib. I don't know why I chose that name. We'll just go through the lines here of what these items mean in here. So the first one loads the dynamic library from wherever it's stored on your machine. You just give it a path and assign it to a variable name. And the second line on here, we load a function, the misleading_name function, out of that dynamic library and assign that. We'll give it a less misleading name. We're going to call it add2. And then the third part here is we're going to declare part of the signature of this file. As I mentioned earlier, the misleading_name function doesn't return anything. We don't care what it returns. So in this case, I am setting the result type to none. I'm telling Python when I call the add2 function, I'm not expecting anything back. So these 4 lines of code here, you can actually just pop into the interactive Python interpreter in the terminal, literally type Python and hit enter on your keyboard, and paste in those 4 lines if you had access to the dynamic library out of this example. And then now you have a function called add2 that you can pass any arbitrary number to it, and it will run the misleading_name function and give you the output. So in 4 lines of Python, we have connected to this previously black box dynamic library and are using external code that we didn't write based on what we found via Hopper and the other commands that are on the operating system. So in fact, we've actually gone a little bit better than what the TrickyGro program does. So the TrickyGro program took no arguments. It just randomly picked a number on its own and grew it by 2. We can actually go one step farther and make it so that we accept a user input of an arbitrary specific number and run the function against that. So already we've improved on the initial tool by going from a non-deterministic tool into one that we have full control over, extra control over. Rather than a random number every time, we can now pass in specific numbers and get back what the result for that specific number is. Again, this is example code that I put together that is very simplistic, designed to look really nice in the pseudocode output for Hopper. If you start going down this route and looking at code trying to investigate what's going on, it'll look a lot messier. But give it a try. You might be surprised. Some of the stuff that's out there is surprisingly straightforward. You just need to know how to call it. I also, the example I gave here was a dynamic library which use C types. The other module that I mentioned, ObjectiveC, the way that you connect to code with that is a little bit different. The signatures are also defined a little bit differently. I actually have a blog post up on my blog called Learn You a Better ObjectiveC Bridge Support Signature at mikeylynn.github.io. That actually has an in-depth from start to finish example of doing this exact type of thing with an Objective-C API. In that particular instance, it was the mount command in AppleScript that everyone likes to use for mounting a volume. We wanted more control than that. The SMB mount commands and all that kind of stuff are not the same as the AppleScript mount verb. The AppleScript one will use your keychain stored passwords or Kerberos sign-on and all that kind of stuff to mount a share. And it'll work with SMB or AFP or whatever you want to do. They were like, well, how the heck does it do that kind of stuff, and can we do it better than that does? This blog post goes through from start to finish my investigation of that and turning it into functional Python code. But also, that blog post was written 2 years ago now, I think, something like that. My style of doing PyObjective-C reverse engineering and bridging and all that kind of stuff has evolved since then. It's gotten a lot cleaner and tighter. And most of those examples you'll actually find in the hundreds and hundreds of gists that I have up on GitHub. This specific bit.ly link that I've got here on the slide will actually take you straight to GitHub and give you the examples that I'd recommend taking a peek at on how to, there's one right on there for the SAC lock screen immediate API. So if you go into keychain access and you turn on the little menu bar item that lets you lock the screen immediately, there's an API that does that. And it's not actually a publicly documented API. So that 10 lines of code there is my entire way of calling that. And so now via Python, no matter what your security settings are, whether you've got the screen, most people who do let's lock the screen now, they initialize the screensaver and then depend on the security settings of the machine to trigger the lock function. This calls that same API and immediately locks the screen no matter what your security settings are. It can be called remotely, it can be worked into tools, all sorts of stuff. Yeah, 10 lines of Python, half of them are white, new lines. And there's more examples there. The Spotlight one is actually the one that's kind of trailing off the bottom of the page there. That one's up there, you can check it out too. Ran a little fast on this one. Okay. Well, it'll give time for Q&A. So some final thoughts here on this. This talk was really geared as a 101 level talk, or maybe even a level 99 kind of talk, just to sort of whet your appetite and get you interested in it and show you that it's not as scary as you might think it be to start reverse engineering items in the operating system. As you saw, a lot of my examples were like 6 or 7 lines of Python to connect into this stuff. More work was put into finding where the code was and what it looked like than actually writing the Python in the end. Once you start writing a few of these things, they all end up looking mostly the same. You just need to figure out where the stuff is. That's the part that's really time intensive more than anything else. But with all this newfound power that you have, comes that great responsibility that you may have heard of. I really did mean it when I said you should be filing a radar when you run into these kinds of automation gaps. Yeah, you might fix it with your tool, but you touch code that is Apple's code. The reason that it's not documented is either, well, several-fold. It's their code to do the things that they want to do, and more importantly, it may change from operating system version to operating system version. The public APIs are relatively stable. Private APIs, it could be a point release OS, and that API that you found that worked in 10.12.5 may be gone in 10.12.6, whenever that lands. Or it may be removed. Yeah, it could just be gone. Or Apple may have said this is really an internal implementation detail, and you shouldn't need to have it. They may actually, if you do connect into and find the API and file a radar on it, they may come back to you and say, oh, we're really surprised that you could even actually use that in the first place. That should have been locked down a heck of a lot more, and they'll actually determine that it's a security vulnerability and lock it down even more. But file that radar, because if you didn't figure out that it was a security vulnerability, someone else might have, and now instead of there being something on the books saying, I need this functionality, it's just gone forever behind a locked door, and Apple doesn't understand that you have a business need for this. If and when that radar gets fulfilled and you get this new functionality, it will become a stable, usable thing for you, which is vastly more dependable than these kind of hacks in the meantime. That being said, thank you for attending this. I'd like to open it up to Q&A at this time. If anybody has any questions. No? Yes? Oh, all right. Oh, good, you closed your laptop.
Is there any clear indicator?
Into it more.
Is there any clear indicator for you that an API that you find or a framework that you find is like private but okay if you use versus no, this is really private, or is it just anybody's guess?
None of them are okay for you to use. I mean, they're okay in the sense of what I was talking about before. You're increasing interoperability, and ideally you have told Apple, I have a need. You can make, they're usable in the sense that it works. The okay to use, some of the functions will have like several underscores underneath them, which is like an indicator that it's really, really private. Or some of them, if you start pulling it open and you start seeing it doing checks like checking to see if the program that's calling this API is signed by Apple, that's usually a really good indicator that this API is not going to be anything you're going to be able to do anything with. Aside from that, yeah, no, there's really no giveaways when you start looking at this kind of stuff that this is like super, super, super don't touch stuff. I mean, it's not a secret, right? They give it to all of us on all of our machines. If they really wanted to make it secret, they could obfuscate it, and when you open it up in Hopper, it would look like total junk. You wouldn't see anything, couldn't make any heads or tails of it. They would put effort into making it difficult to decode what's going on. For the most part, it's just we needed to do this visual feature on the operating system, and so we wrote the code that does it, and that's done. We shipped it 6 months ago, and we don't even give it another thought for the most part. So, yeah, no real indicators. You don't get a word in there that says Apple do not touch or something like that. Oh! Yeah.
So, what is the most interesting thing you found with Hopper, if you can say? And then what's the most interesting thing you've done afterwards? They could be two different things.
Boy. So, I don't know. Interesting from how to actually implement it. It's kind of both one and the same. One of the things that we wanted a hook or a command, or well, that I wanted, based on the request of someone else, was automatic time zone detection is really interesting, right? Like there's the mechanism where your laptop can figure out, I'm in a different part of the world, I need to change my clock. From an imaging standpoint, it'd be really cool if your computers could, no matter where your imaging is globally in the world, automatically determine, hey, I'm in China, or hey, I'm in France, and automatically set the time zone on the computer using the mechanism that Apple uses. There are a couple APIs for enabling location services and that kind of stuff. But there was one thing that I was really interested in finding, which was how to kick it off, how to make it actually do the thing where it runs and figures out where the heck am I. And we noticed that when you open the date and time preferences pane, it kicks it somehow. Like just the act of opening the preference pane triggered the automatic discovery code somehow. So yeah, via Hopper, I went digging into it and found that within the preference pane itself, it called a couple APIs that triggered the time zone stuff. And the part that I liked about that particular project was that, as I mentioned earlier, menu items and preference panes are a special class of application in that they are loadable into a host process. So instead of looking at the dynamic libraries or frameworks that it calls, you could just load the whole menu item in to Python directly, or the whole preference pane directly into Python, and call the code in it directly. The whole thing is loadable into Python. And so instead of finding the dynamic library and digging down all the stuff, I just found the name of the function in the preference pane that runs when it opens. And I don't know, it's like 2 lines of Python or something like that. I just said, hey, date and time preference pane, can you kick the automatic detection thing? And it said, oh yeah, sure, I'll do that for you. And so that got rolled into a couple different Python projects that are out there where, yeah, it loads the date and time preferences bundle into Python via PyObjectiveC and kicks the location services after you've ensured that all the necessary prerequisites are enabled for it to actually work. Because you got to have Wi-Fi on and a couple other things. Like from an implementation standpoint, that was actually really interesting. That was probably the first time that it actually loaded the whole thing, the whole enchilada into Python and just said, you do it for me. That one was fun. Got one back there.
So this one's actually just really easy. The PyObjectiveC, does that connect to OS X frameworks or Objective-C directly? And if Objective-C directly, do you know if there's going to be a PySwift?
So the PyObjectiveC project, I think, uses libffi. Okay, so Apple created the bridging framework that defined a spec for for lots of languages to do exactly this type of thing. Call Objective-C from any language. And it was heavily advertised at first when it initially came out. You could call Objective-C from Java, you could call Objective-C from Python, you could call it from Ruby, you could call it from all these different things. And what they actually made a .bridge support file. It's an XML standard that anybody implementing the bridge support can load the file, and it'll automatically connect all the Objective-C pieces into your language. The XML file contains the arguments, what types of arguments they are, whether they're numbers or strings, and what the return results are. And in fact, that blog post that I mentioned as an example of PyObjective-C bridging, that one actually does that. It uses the XML format. It's the older way that I was doing it. There's a more succinct way that's shorter. Nowadays, the bridging framework is kind of gone to the background. It's not really talked about anymore. And the PyObjective-C project itself uses this thing called libffi that I don't think is necessarily directly related to the bridging framework anymore. So how PyObjective-C does it is, I think, kind of unique to PyObjective-C in this particular instance. It dynamically generates a connection and loads the framework like any other Objective-C application would load the framework. It's literally calling the code directly. I'm not sure if that answers your question on there.
Gotcha, but I see that we can get 100 or 2 radars here asking for PySwift from Apple, maybe.
Oh yeah, PySwift. Whether or not that'll actually exist. Probably not at this point. Like I said, PyObjective-C is a labor of love from Ronald Usorin, and he's amazing. The work that he did for PyObjective-C is just so amazing. And I'm very happy that Apple ships it on the devices, but it is third-party work. And I think, I unfortunately think it would be more likely that Python would disappear out of Mac OS than I would see PySwift appear on Mac OS at this point, at the way things are going.
I'll follow up to that. What would you use PySwift for? And the reason why I'm asking that is because it sounds like what you want to do is access the Mac OS frameworks. As long as all of Mac OS's frameworks are accessible via Objective-C and Swift, does it really matter? In other words, a PySwift wouldn't get you anything new. It would just change the syntax that you would be using to access it. Now how do we do this back and forth? Okay.
Until there's a time where there's Swift-only frameworks.
Right, which hasn't happened yet as far as we know.
Okay, gotcha.
So if that happens, maybe you'll see it. I wouldn't hold my breath.
Okay. So I'll ask again in a couple of years. Siri, remind me.
And I'll say, Python, why are you still using Python? No. Anyone else? All right, I think we're good. Okay. Thanks everyone for being here.